Hello, in this video we will be looking at simple rational graphs with transformations as well. So these are two different graphs we're looking at. The first one is f of x is 1 over x, and then our second graph is going to be f of x equals 1 over x squared. Before I start anything, I want to actually think about the domain of this equation. Because this is a rational function, that means to find the domain, we're going to set our denominator not equal to 0. So that means x cannot be 0. And what we've been doing the last few days, this means our domain, we would have 0, we'd have an open circle at 0, and everything else works. So the domain is going to go from negative infinity to 0, and then union 0 to infinity. Which means at the y-axis, we are not going to be able to cross that y-axis at all. Now, the way that we're going to show that we can't cross the y-axis in this case is we are going to put an asymptote. And that asymptote ends up being the equation x equals 0. So where the issue with our domain actually creates the asymptote. So to find the asymptote, it's the same thing as finding the domain, except for this time we're looking at the denominator is equal to 0. So we're going to have an asymptote at x equals 0, which is that pink line that's drawn in there. So now what does the rest of this graph look like? Well, in order to get the rest of the graph, I'm going to make a quick table. So my table is going to be x and then f of x. And I'm going to put in, let's go, -2, -1. I'm going to put in -1/2, and you'll see why in a minute. We know that 0 doesn't work, so there's no reason to put that in there. And then I'm going to put 1/2, 1, and 2. So now what happens here? Well, f of x is going to be 1 over -2. So at -2, we're at -1/2. At 1, 1 over -1 gets us -1. I don't know why I put that previous point in the wrong spot. This previous point should be down at -1/2 instead of +1/2. So it's going to be down here. What the heck? We lost the eraser. We're using the eraser instead of the pen. That's what's going on. So let me put my axis back in there. So my axis is there, and the asymptote is there as well. So now the point is -2, -1/2. We're going to have another one at -1, -1. At -1/2, we're going to have 1 divided by -1/2. Well, really what we have here is we multiply by the reciprocal, and we end up with the value of -2. So when we're at 1/2, we're at -2. So what's happening is the graph is going to look something like this. Okay, it's going to be like half of a curve on this side. Now, when we do +1/2, we get 1 divided by +1/2, gets us 2 over 1. And that's going to get us +2. So at 1/2, we're going to be at +2. At 1, 1 over 1 gets us 1, so 1, 1. And then 2 would get us to 1/2. So what happens is that the curve does this on the other side. And this is actually going to create a second asymptote. And that second asymptote is going to be the horizontal line that goes through at y equals 0. So we're going to have another horizontal asymptote at y equals 0. Now, what happens when we square these? Well, we're going to start by doing the domain the same way. So the domain, we're going to say x squared does not equal 0. So that means x cannot be 0. So our domain ends up from -infinity to 0, union 0 to infinity. And then what happens with the graph is, even if we were using these exact same points, if I just put another column and I make this 1 over x squared for the table, what this becomes is 1 over +4. It would then become +1. This one would be squared and become +4. This would be squared and it would become +4, 1, and then +1/4. So what happens with this graph? Well, we're going to have the same asymptotes. The asymptotes will still be at x equals 0 and y equals 0. So we're going to have two asymptotes. And those are going to be x equals 0 and y equals 0. But now in this case, our graph is going to do this. The two curves are both in the positive axis. Now, the other thing that this graph creates is, or that we need to look at with this graph, is the range. The range is the y value. And I'll be honest, these ranges are dealing with where the asymptote is. In this first graph, because we're going up and down compared to the asymptote, our range is negative infinity to 0, union 0 to infinity. On this second example, our range is only going in the positive direction. So that means our range is 0 to infinity. Now, let's look at some other options. So now we're going to look at these in terms of transformations. So what happens when we put some values in here? First off, our h and our k are the same movements they were with our other transformations. When we did, let's say, f of x is equal to x minus 2 squared plus 1, that moved us to the right 2 and up 1. These transformations are going to do the same thing. So if we're given f of x is equal to, and we'll just make this 1 over x minus 2 and then plus 1, what will that do to the graph? Well, the first thing is it's going to change our domain. And what we're going to do is we're going to start by setting our denominator equal to 0. So in this case, x, or not equal to 0, x cannot equal positive 2. Which also means then we have a vertical asymptote at x equals 2. So what's going to happen is we're going to go to positive 2, and I'm going to put an asymptote in there. So I'm going to draw in a vertical line at x equals 2. Now, the value on the outside, that is going to represent where our horizontal asymptote is. So our horizontal asymptote is going to be at that value, y equals 1. So at y equals 1, I'm going to go through and I'm going to have a horizontal asymptote in there. So now, because this is positive and a single x, it's not x squared, that means our graph is going to be diagonally across in the positive direction. So what I mean by that is, I mean, when you look at where these curves are, if we were to draw a slope line between the two curves, the slope, that blue slope, has a positive slope. If it was negative, the curve would be on the other side of our dotted asymptotes. So what happens here? I didn't write it, but from the domain is negative infinity to 2, union 2 to infinity, because everything works besides 2. Our range is from the horizontal asymptote, and it's going to be negative infinity to 1, union 1 to infinity. So now let's look at another example. So our next example is, we're dealing with a few things here. One, we need to recognize the fact that our equation is squared. So that means the typical parent function is both on the top. But we also have a negative. So what happens when we have a negative a value? Well, that's going to be a flip across the x-axis. So what does that mean? That means instead of the two pieces going up on both sides, they're going to be going down on both sides. But we still need to worry about where are the asymptotes. We always need to start with the asymptotes. So how do we find the asymptotes again? To find the asymptotes, we need to start by finding our domain. In order to find the domain, we're going to set our denominator, x minus 3, not equal to 0. So that means x cannot be positive 3. So that gives us the domain of negative infinity to 3, union 3 to infinity. That is our domain. So what that really means, though, is that at positive 3, 1, 2, 3, we're going to have a dotted line that our graph cannot cross. That gives us a vertical asymptote at the equation x equals 3. We're now going to use that information to figure out where is the horizontal asymptote, and that is based off of the k value at the end. So our horizontal asymptote is going to be at y equals negative 1. We're going to go down to negative 1 and put in an asymptote there. And the horizontal asymptote, that creates our range. So our range, well, actually, let me draw it first. So with this one, the graph is based off of this piece here where The two sides are going down. Now I have something that kind of looks like a brain, and it's going down on both sides of the graph because of the negative. So our range, well, the highest point of our range is our asymptote, and it's going all the way down to the bottom. So the range is negative infinity to -1, because that's where the horizontal asymptote is, and then parentheses. With this 1 over x squared, one of the things that you need to know is the following. So when we talk about domain and range for these, so let's look at our overall domain and the range. And we're going to look at 1 over x minus h plus k, and then 1 over x minus h squared plus k. And then our last one is -1 over x minus h squared plus k. So what happens? Well, the domain for this, whether it is positive 1 over x minus h or negative 1 over x minus h plus k, whether you have a positive or negative here, it doesn't change. The domain is negative infinity to h union h to infinity, because the h represents the vertical asymptote. The range is negative infinity to k union k to infinity, because the k represents the horizontal asymptote. For 1 over x squared, if it's positive, our domain is going to be the same as before, negative infinity to h union h to infinity. But the range, because this graph is up on both sides, this range is going to be parentheses k to infinity, because we can't include the k value because that's an asymptote. For our last one, our domain still has not changed, negative infinity to h union h to infinity. But this time our graph is upside down, so that means our range is negative infinity to k. Hopefully this will help with clarifying some of that domain and range.